In this video, you will learn how to model and solve design problems involving maximums, minimums, and exact values. For example, suppose a bakery sells cakes with a diameter of 10 inches, and they wish to pack each cake into a box that is in the shape of a rectangular prism with a height of 8 inches, so that the cake does not get crushed. Even though we are not given any additional information about the box, we know that the cake has a diameter of 10 inches. This means the length and width of the box material to close a fixed area must be 10 inches or more so that the cake will fit. This means we can find the volume of the smallest box the bakery could use would have a length of 10 inches, a width of 10 inches, and a height of 8 inches. So the minimum volume of an acceptable cake box would be 800 cubic inches. Let's look at some other questions. Nico has 36 feet of fencing that he will use to enclose a rectangular garden. He will construct the fence so that none of the fencing overlaps and all the fencing is used. What is the maximum area rectangle he can enclose for his garden? We know Nico has 36 feet of fencing. He is making a rectangle, and he is using all the fencing with no overlap. So the perimeter of the garden is 36, and the length and width have a sum of 18. Let's explore some potential lengths and widths with a table and look for a pattern. When the length is 1, the width is 17, and the area is 17 square feet. A 3 by 15 rectangle has an area of 45 square feet. A 6 by 12 rectangle has an area of 72 square feet. 8 by 10 has an area of 80 square feet. When the length is 9, the figure is a square and the area is 81 square feet. After that, we repeat the combinations. 12 by 6 is the same as 6 by 12. 15 by 3 is the same as 3 by 15. You can see that a 9 foot by 9 foot square gives the greatest area. So the maximum area rectangle Nico could enclose for his garden is 81 square feet. Let's look at another question. Pamela must use a box in the shape of a rectangular prism to ship a volleyball with a diameter of 20 centimeters to her sister. What is the volume of the smallest box that Pamela can use to ship the volleyball? As in our earlier example, we use the size of the object being placed in the box as the smallest possible size of the box. So, the smallest box Pamela could use would be 20 centimeters long, 20 centimeters wide, and 20 centimeters high. And the volume of a rectangular prism is the product of the length, the width, and the height. So the smallest box that Pamela could use would be a box with a volume of 8,000 cubic centimeters. Now you know more about how to solve 2- and 3-dimensional design problems involving maximum, minimums, and exact values. Thanks for watching.